Alright, physics lesson 4.4, graphing in 2 dimensions. Alright, so with 4.3, we added a second dimension to our equations and our problems that we are looking at. So now we're not only moving left or right, but we are also moving up or down. So there's a little bit of a problem with graphing, because when we were graphing before, well, we had time over here, and then either delta x or delta y over here. The problem is, now we have to have both of these variables and time on the same graph. So how we're going to be able to do that depends on a couple of key features, a couple of rules. Okay, so rule number 1, you need to do all of your calculations first. So you need to put every number that you have in, otherwise you're not going to be able to do this. Second thing, you need to make a table. Make a table for x, for y, and for time. Remember, the time for y is going to be the same as time for x. And then last but not least, then you plot your values as ordered pairs. So what you're going to end up doing is having an ordered pair like this, x and y. Then at the very end, we're going to go ahead and add in a third one, which is time. And time, we'll have it linked to x, because x is our constant velocity. So it's going to be constantly moving at that rate, so that time is going to be going by that same rate. That will make things a little bit easier when we're plotting things out. Alright, so practice-wise, we have a cannon, same cannon, shooting a cannonball off of a cliff. Only difference is this cliff is going to be huge, 500 meters. There's a reason why I made it that big, and it's going to be going this way at 40 meters per second. So if you remember from 4.3, the horizontal value is this. That's our Vx. We don't know what our Vy is yet. The only thing we know is that Vy initial is 0. We don't know what it is over here, and it doesn't really matter. It's it's going to fall down. We'll figure that out later and how fast it's going, because we'd have to look at a vector, and let's just keep things as simple as we can. We do know that our delta y is going to be 500. So you need to solve for all of these variables. Time, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is just a standard times that we're going by for this table. If you're looking at your Nerf gun lab and you're like, that bullet didn't go up. It wasn't in the air for 10 seconds. Well, what do I do? How long it was in the air? Find about 5 points. Then you can plot those. But for this problem, we're just keeping everything as 10. Then, let's go ahead and fill out our delta x, because delta x is velocity times time, right? Remember our velocity equals delta x over t formula? All we're going to do is substitute in those times. So these are going to end up being 0, 40, 80, 120, 160, 200, 240, 280, 320, 360, 400. So that means that on our graph, our delta x is going to go all the way this way to 400. At least 400. You can actually end up scaling the whole thing and making it a little bit easier that way. But we're going to make it 400. And I'm going to make this slightly smaller just so that we can get some graphing in. Alright, so delta y. This is the trickier part. Delta y, we're going to have to use an equation, just like we did from before, to figure out our delta y. Only problem is, we have to substitute all of these times in. So, let's get a new page. let's look at our formula. Delta y equals 1/2 at squared plus velocity initial times time. Velocity initial, still going to be 0, so we can just cancel that part out. Our acceleration of gravity is -10, so 1/2 of that is -5 squared, and our delta y is going to be 500. Now, after we solve for this is going to give us the time that it's going to take to fall for this. So, we should end up with a time of 10 seconds. What? That's so weird, because that's exactly what I have this scale to. So I know that it's going to fall down to -500. The trick is, where does it fall in between? So, we don't know our delta y. What we do know is these time values that we're adding in. So delta y equals -5, right? Still the same. 1 squared. Delta y equals -5, 2 squared. Delta y equals -5, 3 squared. Squared. Alright, and then you can fill in the rest of those here. Time-wise, I just want to jump right into the graphing part, because that's the important part. Alright, so with this graphing, this is delta y over here. Delta x is going to be up here. Why is it on top rather than on bottom? Well, if this part right here is our origin, delta x is moving forward, delta y is moving down, right? Because everything's falling down. Now this is scale-wise. This should be going, each little of these squares should be 20. So, -40, -80, -120. And the same thing is going to go over here, but going positive. So 40. Let me get positive. I'm just trying to make little dash marks. It's a little bit harder to write with this like that. I need to make things smaller. 80. 120. Alright. And then we can start plotting some points. I'll do the first couple, and that should give you a sense of how this table is going to plot out. I'm not going to do the whole thing just because I'm limited on my time that these videos can be. Alright, anyways, so here's our origin, right? 0, 0. Then, after 1 second, the delta x is at 40 and delta y is at -5. So, it's going to be here. That's 20, 10, right about there. Then we can plot our next point. 80 and -20. 80. It's off a little bit. Right. That should be 80. This is just off a little bit. And then our next point, 120 and -45. So 80, 100, 120. There's 40. 45. And you're going to start to see this pattern start to emerge. And it's going to go all the way down, and that should match up with what we were talking about with 4.3. Alright, now the last little piece of information is time. Time you want to hold off to the end. Time I like to have on the bottom. Some people don't like to have time. I like to have time. So we're calculating for it, we might as well have time. So I always put time on the bottom. It's on the x-axis still, it's just now I have two x-axes. Now because it's tied to our horizontal velocity, then it's going to match, right? 40 meters per second. So it went 40 meters per 1 second. 2 seconds. 3 seconds. 4 seconds. And that will go all the way across. All right. That should wrap it up. Hopefully your graph starts ending up looking like the previous part. And have a good day.